On a bright November morning in 2010, Qantas Airlines Flight 32 took off from Singapore's Changi airport. The Airbus A380 climbed steadily into the clear blue skies. The 469 passengers on board were being carried towards Sydney, Australia. Passengers had settled in their seats, enjoying the hum of the engines, which held the promise of an otherwise uneventful flight. But just 4 minutes after takeoff, disaster struck. A deafening explosion tore the serenity of sky, shaking the plane violently. Those near the left wing watched in horror as thick smoke started billowing into the air. In the cockpit, alarms shrieked incessantly and flooded the pilots with critical errors. The system started failing one by one as the crew faced a catastrophic reality that their aircraft was crippled, and they happened to be thousands of feet above the ground. Could the pilots possibly regain control of an aircraft, facing what seemed like an unstoppable chain of failures? This is the incredible story of Qantas Airlines Flight 32. On November 4th, 2010, Qantas Airlines Flight 32 was scheduled for a long-haul flight over international waters from London to Sydney. For the Australian flag carrier, the route though was extremely popular. A few hours ago, it had landed in Singapore after hours of flying for its 2-hour refueling and onboarding more passengers, including a new crew for the last leg to Australia. The aircraft, an Airbus A380 was a relatively new addition to the Qantas fleet. It was registered as VHOQA and nicknamed Nancy Bird Walton after one of Australia's most celebrated aviators. Just over 2 years had passed since this specific A380 was put into service. 4 enormous Rolls-Royce RB211 Trent 900 series high bypass turbofan engines, each capable of generating up to 84,000 lb-f of thrust, powered the Airbus A380. It was then the largest and most advanced passenger aircraft in the world. Weather conditions were near perfect on that day. There was light wind blowing, and skies over Singapore were clear with no adverse reports forecast for the flight route to Sydney. The aircraft had 469 people, 440 passengers, and 29 crew members. With such an advanced aircraft, combined with excellent weather, no one could imagine what drama that soon would unfold. The Qantas 32's flight crew was one of the most experienced crews imaginable. At its helm was Captain Richard de Crespigny, who had over 35 years behind the controls of an aircraft. By reputation, he was known for his calm demeanor and being a precise flyer. De Crespigny had piloted a wide range of aircraft during his career, and his familiarity with the Airbus A380 was particularly notable. There were 5 pilots in the cockpit of this flight. Assisting the captain were a First Officer Matt Hicks and a Second Officer Mark Johnson, both of whom were well-trained and proficient in handling situations of high complexity. On board additionally were 2 check captains, Check Captain Harry Wubbin and Senior Check Captain David Evans, veteran pilots charged with ensuring operational standards. The crew were between 19 to 61 years of age, with mixed nationalities with differing experience levels. Their combined expertise would prove crucial in the hours to come. The crew put forth a lot of effort in the cabin to guarantee the safety and comfort of the passengers. Having received crisis management training, their expertise would eventually be crucial in preserving order during the emergency situation that would soon arise. Qantas Flight 32 took off at 9:56 a.m., local time from Singapore's Changi airport. As the crew went through the preparations in the cockpit, the captain asked if everyone was happy. The first officer darkly remarked, "Yep, don't crash." With the boarding completed, the safety demonstrations took place, and the door was closed as standard procedure. The 4 64-tons aircraft accelerated down the runway. The Airbus A380 took off smoothly from the runway at a speed of 350 kilometers per hour, with 4 Rolls-Royce Trent 900 engines lifting it to its cruising altitude. The aircraft covered its first leg, which was relatively uneventful, and was gliding over the island of Batam in Indonesia just mere minutes after takeoff at 7,000 feet. The passengers settled into their routine, while for the flight crew, it was business as usual. The electronic centralized aircraft monitoring system gathers data to monitor 1320 checklists. For this checklist, ECAM verified that all systems had indeed transitioned from takeoff mode to the configurations needed for climbing and then cruising. With all the pre-flight checks completed, the takeoff executed flawlessly. Little did they know that this tranquility would be shattered in mere moments. The airplane continued to climb to 7,400 feet, and at 10:01 a.m., the pilot was just about to turn off the seatbelt sign when they heard a relatively small boom. Then, another very loud explosion echoed through the cabin, jolting passengers and crew alike. The source of the blast was engine number 2, located on the left wing. Some fragments of debris from the airplane engine had punched holes in the wing and damaged the fuel system, which resulted in a leakage that caused a fuel tank fire. The engine was destroyed in the explosion. For Captain de Crespigny and his crew, there was the imperative to level out the aircraft first and understand how much damage had occurred. They yawed to the left slightly, and autothrust disconnected. The captain leveled the aircraft. In the cockpit, over 50 error messages flashed through the electronic centralized aircraft monitor in rapid succession. There were numerous problems to deal with, and each had devastating effects. The failure of the number 2 engine and subsequent debris damage had cascading effects. Damage to the anti-lock braking system raised the possibility of instability during landing, while the weakened hydraulic system made it more difficult for the aircraft to manage its landing gear, flaps, and flats. The fuel leakage and hot surfaces from the damaged engine posed a major fire hazard. The degraded engines meant reduced thrust, complicating the maintenance of the altitude and stability. All these together presented a perilous situation, requiring immediate assessment and action to prevent catastrophic consequences. As the crew fought to overcome the immediate result of the explosion, the list of problems seemed to grow and grow. The crew could only partially shut down the damaged engine as it continued leaking fuel. Of the aircraft's 22 different systems, 21 were damaged, and a total of 650 wires and network cables were cut. The fire suppression system for the damaged engine was inoperative as well, so the crew had no means of extinguishing any fires that might have ignited. It was difficult for the cabin crew and the pilots to communicate. Debris had landed onto Batam Island, adding to the stress, and passengers could see the damaged wing and leaking fuel in real time on the in-flight entertainment system. Every choice had life or death consequences in the chaotic cockpit caused by the chain of problems that had occurred. The procedures the captain had learned to manage crises were failing him. He figured there had to be another way out of this complicated situation. The crew worked to stabilize the aircraft using the Airbus A380's extensive redundancy systems. Fuel dumping, which is a crucial stage in lowering the aircraft's weight for landing, was initiated. 40 to 50 seconds after the issue began, the crew contacted Singapore Air Traffic Control and sent out a message. The crew prioritized procedures that would maintain the integrity of the aircraft, while carefully going over the electronic centralized aircraft monitor messages, or ECAM in short. Every choice they made was well thought out and demonstrated their in-depth knowledge of the A380's limitations and systems. In the passenger cabin, the atmosphere was a mix of confusion and fear. Those seated near the left wing reported seeing flames and hearing the explosion. Tension hung thick in the air in the cabin. Despite their own fears, cabin crew members moved swiftly to reassure passengers, trying to maintain calm and order. The most critical decision came as the aircraft neared Changi Airport. At that point, the crew had to decide whether to land immediately or wait to action all of the abnormal procedures associated with the dozens of ECAM messages. It took them almost 55 minutes to clear all of the ECAM alerts, and they were more than 40 tons over the permissible landing weight. After determining that the aircraft could be controlled with the autopilot turned on and off, they ultimately decided that it was safe to stay in the air and that it would be preferable to ensure that every crew member was fully aware of the status of every system in the aircraft before landing. The last thing they needed was a surprise on the final approach that would force them to go around. After deciding on this course of action, the crew requested ATC for permission to circle over the ocean northeast of Singapore and enter a holding pattern. In preparation for landing, the cabin crew secured the cabin and climbed into their jump seats. Captain de Crespigny decided to deploy partial flaps and rely on the 3 remaining engines to manage the descent. 11:45 a.m., Qantas Flight 32 made its final approach to runway 20C at Changi Airport. The landing demonstrated exceptional skill, but the challenges weren't over yet. With damaged braking and reverse thrust systems, the plane's ability to slow down was compromised. Fuel was still leaking, so the personnel informed the ATC that fire trucks were needed. The pilots managed to bring the aircraft to a halt, narrowly avoiding an overrun using the remaining functional systems. 4 tires were blown due to the airplane landing faster than normal. The crew faced another issue after landing. Engine number 1 couldn't be shut down as fuel was leaking near the brakes, which were likely overheated from intense braking. Damage to systems in the wing had made the fuel shutoff valves inoperative, which prevented the crew from shutting the engine down normally, due to which the crew debated whether to evacuate immediately or not, as emergency escape slides can be injurious to the passengers. Firefighters were already addressing the fuel leak and cooling the running engine. With the situation under control, the crew decided the safest option was to deplane through the stairs on the right side. Once the door was disarmed and stairs were attached, the passengers started disembarking the plane. Miraculously, all 469 people on board survived the ordeal, and the passengers and crew were evacuated without reported injuries. Responding emergency personnel praised the skills and composure of the pilots involved in handling the incident, crediting them for averting a catastrophe that would have resulted in the loss of several lives. The incident was the subject of an extensive investigation by the Australian Transport Safety Bureau. Their investigation revealed that the Rolls-Royce Trent 900 engine had a manufacturing defect. The catastrophic engine failure resulted from a fire triggered by a misaligned oil pipe. Rolls-Royce came under heavy scrutiny, and airlines using Trent 900 engine were instructed to start inspecting them right away. The tragedy revealed vulnerabilities in engine production procedures, prompting design changes to stop such incidents in the future. The incident led Qantas to upgrade its maintenance and safety practices. It has also led to much stricter industry standards for safety and design. Flight 32 remains an important case study in aviation safety training. Don't forget to like and subscribe. We'll see you in the next one.